Parker Motion Manager has two 4-channel scopes. They're identical between scope 1 and scope 2. I've already done some testing and modification with scope 1. If we take a look at scope 2, if you click on motion, this will be the default code in here. This is your test code. You can change this as you want. If I wanted to run this on axis 1, I just change the local variable to 1. This will do a 1 rev move out and then wait 1 second and then move back. This will get downloaded to program 14, which is where we store we capture the arrays. So all the data is captured in local arrays in program 14 and then uploaded and displayed on the computer. So we move out 1 rev, wait 1 second, then move back. And I'm only running axis 1, so my other encoder positions aren't changing, so those are all just 0. If I click on sampling, you can see the default is 20 milliseconds is the PC-based sampling, so we're capturing data every 20 milliseconds. We can also capture it from onboard, so I could change it to onboard sampling, which case then it'll capture it on board and then upload to the graph. I would just need to come in here and make sure I've got axis 1 selected, since I'm running the motion on axis 1 instead of axis 0, and then select my jog active bit. Then I'll do the motion. It'll do the motion and then capture it and then upload it. Now if I click run, it'll run constantly. This can be helpful if you're adjusting the tuning gains. So you're just running constantly and then adjusting the tuning gains, or you could see the variation after every cycle as well. If I can click stop, if you click display data, this has all the data in a comma separated value format in a text file, so you can see we're capturing it every 2 milliseconds, and this is our 4 channels, and so we could then import that in Excel and do whatever manipulation or data analysis that we want from there. If we click export data, it's the same format. It's just allowing us to save it to our desktop or wherever. And on scope 1, I've adjusted my motion code. I'm actually doing axis 1 and axis 2. So then here's the 4-channel scopes. I've got the actual torque for axis 1, that's the position, actual torque for axis 2, and then actual position for axis 2. We can erase the graph by clicking erase, and then if we want to run again, the other trick is if you want to graph your motion and your motion is already in program 0, what you can do is just type run prog 0. So this will get downloaded to program 14. The arrays will be within program 14 and captured within program 14 and displayed, and all it's doing is running program 0. So this is doing a YZ move as an interpolated move, so I would want to come into my sampling, change it from the jog active to actually the master bit, the in motion bit. So there's my actual position. I'm doing a tiered move, and then you can see the actual torque. I've got some mechanical load actuators, so there's some friction periodicity with the ball screw, but that is actually a very tiny amount of torque. You can see the auto scale is zooming into a very small range, and so if you have that turned on by default, it may look like a very wide range, but in actuality, if you float your mouse over the scope, you can see the actual data, which is a nice feature. Thanks.